The vast, ongoing search for other worlds continues to captivate scientists and dreamers alike. Despite significant progress in recent decades, with more than 7,400 exoplanets now officially catalogued, humanity has yet to uncover a planet that mirrors Earth in all the ways that truly matter. The elusive cosmic twin of our home still lurks somewhere in the galactic shadows waiting to be found. Still, there's reason to believe that this next potentially habitable world might not be as far away as once imagined. One of the most intriguing candidates is Proxima b, a rocky exoplanet orbiting the star Proxima Centauri, located a mere 4.2 light-years away. This might sound like an inconceivable distance, but in cosmic terms, it's virtually on our doorstep. Yet Proxima b isn't just another rocky body drifting around a distant sun. It resides within what scientists call the habitable zone of its star, the region where temperatures might allow liquid water to exist on the surface. And where there's water, the potential for life follows. So what have astronomers discovered about this nearby world since its detection? Could it truly be a second Earth? Is there any chance life could have already taken root there? And what can the tools of modern astronomy like the James Webb Space Telescope actually tell us about it? These are the questions that drive ongoing investigation and fuel the dreams of planetary scientists. To understand why Proxima b holds such fascination, we must start with its star, Proxima Centauri. This dim red dwarf is the closest stellar neighbor to our Sun, lying just 4.4 light-years away. Though the phrase light-year sounds like a manageable hop through space, it's anything but. A single light-year represents the distance light travels in a vacuum over the course of a year, roughly 9.46 trillion kilometers. Multiply that by 4, and the space between our Sun and Proxima Centauri exceeds 40 trillion kilometers, a distance far beyond the reach of current space probes. Despite being relatively close on a galactic scale, Proxima Centauri remains inaccessible for now. Even the fastest spacecraft humanity has built would take thousands of years to reach it. While research agencies like NASA are exploring theoretical methods of interstellar travel such as solar sails or fusion-powered drives, these remain ideas on paper or in experimental stages. As a result, we must rely on telescopes and indirect methods to study this neighboring system. Interestingly, Proxima Centauri does not journey through space alone. Current data indicates it hosts a compact planetary system with at least 3 confirmed planets. The smallest and most recently discovered of the trio is Proxima d, which has just a quarter of Earth's mass and orbits extremely close to its star, likely making it far too hot to support life. Another candidate, Proxima c, lies farther out and is believed to resemble a mini Neptune. It likely has a thick atmosphere and possibly even rings, though it's less suitable for life as we know it. But the crown jewel of the system remains Proxima b. First identified in 2016, this planet has captivated astronomers due to its mass, orbital position, and potential habitability. But just how similar is Proxima b to Earth? The challenge begins with detection. Despite how advanced modern telescopes are, finding exoplanets tens of trillions of kilometers away isn't as simple as pointing a lens at the sky and snapping a photo. Most exoplanets are discovered using indirect detection techniques. The most widely used is the transit method, which tracks periodic dips in a star's brightness caused by a planet passing in front of it. This technique is responsible for identifying around 70% of known exoplanets. Proxima b, however, was not found this way. Instead, its discovery was the result of the radial velocity method. When a planet orbits a star, the gravitational tug-of-war between the two causes the star to wobble slightly. This motion, though minuscule, creates detectable shifts in the star's spectrum. By carefully measuring these changes over time, astronomers can infer the presence of a planet. In Proxima b's case, this method revealed a planet with a minimum mass 1.17 times that of Earth, orbiting within the habitable zone. The term habitable zone refers to the region around a star where conditions are just right for liquid water to exist, not too hot and not too cold. However, being in this zone doesn't guarantee a planet is truly habitable. Many other factors, including atmospheric composition, surface pressure, and magnetic shielding, come into play. For Proxima b, the story is complex. At first glance, its short orbital period might seem alarming. While Earth takes 365 days to circle the Sun, Proxima b completes its orbit in just 11 Earth days. This rapid orbit is due to the planet's close proximity to its star only 7 million kilometers away. For comparison, Earth orbits the Sun at an average distance of 150 million kilometers. Such closeness would typically suggest extreme surface temperatures. However, Proxima Centauri is a red dwarf smaller and cooler than our Sun, emitting only a fraction of its energy. Even so, Proxima b faces another unique condition, tidal locking. This means the planet rotates in such a way that one side always faces the star, while the other remains in eternal darkness, much like the Moon's relationship with Earth. This results in dramatic temperature differences between the blistering hot day side and the frozen night side. Still, scientists believe a narrow band between these two extremes, the so-called twilight zone, could offer stable, temperate conditions where life-sustaining water might persist. Recent climate simulations support this theory. They suggest that if Proxima b has water stored as ice on the cold side, it could melt near the habitable twilight zone, feeding lakes or rivers. This dynamic would create a unique and potentially life-friendly environment, not globally temperate like Earth, but with localized zones capable of supporting ecosystems. But the question remains, does life already exist there? We simply don't know yet. While models have suggested that under the right conditions, particularly with a suitable atmosphere, liquid water could exist, confirmation is still pending. A 2017 study concluded that if Proxima b has an Earth-like atmosphere and correct orbital orientation, its surface could host stable pools of cool water. But these assumptions are far from proven. The planet's actual habitability remains uncertain, primarily due to the unpredictable nature of its host star. Proxima Centauri is notorious for its flares. Like our own Sun, it periodically emits bursts of radiation, but the magnitude of its outbursts far exceeds anything seen in our solar system. In one observed event, the star's ultraviolet radiation output increased 14,000 times in just a few seconds, an explosion of energy more than 100 times stronger than the most powerful solar flare ever recorded. These frequent, violent outbursts could destroy a nearby planet's atmosphere, making the surface uninhabitable. Yet there's hope. If Proxima b has a molten, iron-rich core like Earth, it could generate a protective magnetic field. Such a magnetosphere would shield the planet from harmful stellar radiation and prevent the erosion of its atmosphere. Another theory suggests Proxima b might have originated much farther from its star, accumulating a vast supply of water before migrating inward. If so, it may have initially contained up to 10 times as much water as Earth. Even if 90% of that was lost due to radiation, the remaining amount could still form massive oceans, especially in the more temperate twilight zone. So what about the rumors that the James Webb Space Telescope has already photographed alien city lights on Proxima b? And what's the truth behind the strange radio signals reportedly picked up from the Proxima system? These are cases of misinformation and misinterpretation. The claim about city lights stems from an observation involving the brown dwarf W1935, not Proxima b. The Webb telescope detected fascinating methane-induced glows around W1935 phenomena that some enthusiasts hastily labeled as artificial lighting. But the claim has no basis in reality. The lights are natural, chemical in origin, and not linked to Proxima b at all. As for the radio signal, there is a kernel of truth, but with an important caveat. The Breakthrough Listen initiative once detected a signal known as BLC1 from the direction of Proxima Centauri. Initially, it was considered a potential sign of intelligent origin, but further analysis revealed the signal had earthly roots. It was simply the distorted result of terrestrial radio interference. Thus, the mystery faded. To date, the WOW signal detected in 1977 remains the most intriguing potential message from an extraterrestrial source. It has never been repeated or explained, and while it may still have a mundane origin, it continues to stand as one of the most enigmatic signals ever received. In the end, Proxima b remains an enigmatic, tantalizing world so close by cosmic standards, yet still impossibly distant. As telescopes improve and new detection methods evolve, we may one day learn whether it's a desolate rock battered by stellar fury or a haven harboring the quiet stirrings of life. Until then, the mystery endures.